Okay, so now we're recording for everybody at home. So for number 4, when we want to solve for an angle, right, we want to get rid of the tangent, but we want to keep the theta there. So we can't divide tangent without dividing also the angle. So the only way to solve for an unknown angle is to do the inverse. So we're going to do tan -1 of 34.128. In our calculators, that's where we go second tan, 34.128, and we're going to get 88.32163061. But what did I ask to round to? To the nearest second, which means I want this answer in degrees, minutes, and seconds. Does anybody remember how we get degrees, minutes, and seconds given a decimal?
Yeah, do that, and then you go into second apps and then DMS.
You got it. Second apps DMS, which I believe is choice 4.
Yeah.
And so now, second apps choice 4, enter. You are going to get 88 degrees, 19 minutes, and it's 17.87 seconds. So that's going to be 18 seconds if we're rounding to the nearest second. All right, number 5's the tricky one here. It's tricky because we don't have a cosecant on this. So what we want to do, I'll show my work over here. I have the cosecant of theta is equal to 3.4561. Because there is no cosecant button on our calculator, we have to figure out which one is cosecant related to. Oh, is that not the number? Oh, I have it written down wrong? Okay, so 42.179. That better? Okay. All right, so what is cosecant related to? Sine. So isn't cosecant the reciprocal of sine? We're going to use sine to the negative first, but what we want to do is we're going to do sine to the negative first, but it's not going to be a 42.179 because it's the reciprocal of it, right? So it's 1 over 42.179. And now I want you to round this to the nearest second and tell me what you get. I'm doing it on my calculator. I could show you. Let's go to our calculator. So to enter this into the calculator, so we're going to do second cosine. That gives us the sine to the negative first power. And then you're going to do 1 division sine. What is it? 42.179. Enter. Right, so this would be the decimal, but I don't want the decimal because I want degrees, minutes, and seconds. So what you're going to do is you're going to go to second apps, choice 4, and then enter. So we're 1 degree, 21 minutes, and 31 seconds. You got it. So you guys try number 6, and negative is okay. A negative answer is fine. We'll take it. Oh, give me 1 second. All right, now I'm ready. Oh, wait, no, degrees, minutes, seconds. Okay, now I'm ready. So whenever you're ready, just hold it up for me. Just one negative in the front. I wouldn't make the second one. So it's negative 31 and then, yeah, 43. That's showing that it's all negative. Perfect. What happened, Charles? Are you in degrees? Are you in radians? Check mode. Okay, so let me see how you typed it in. Did you type in sine or negative or the inverse of sine?
Sine.
You want the inverse of sine. That's the whole point of this, right? Because we have to solve for theta to get rid of the sine. No, Aaron. Phone away. Phone away. Phone away. Phone away. Wake up. Wake up. No. Okay, so what should you guys have done here? For number 6, again, we're solving for theta. So then we're going to say sine to the negative first power, the inverse of sine of negative 0.5258. And then you're going to do second apps, choice 4, enter, and you should get theta is equal to approximately negative 31 degrees, 43 minutes, and 20 seconds. Anybody need to see me type that into the calculator? No? Okay. So now the triangle problems. So I'll do the first one with you and you guys will do the second one on your own. So we want to, there should be a right angle here, which I believe is in the review. I drew it in. So angle A is 34 degrees and 19 minutes. AC is 17.581 units long. And first thing we want to do is find the measure of angle B. Well, remember, a whole triangle has to add up to 180. All the angles in the interior of a triangle have to add up to 180. So if I have 2 of the angles and I just need to find the other one, well, I know one is 90. So 180 minus 90 is 90, which means angle B is going to be 90 minus 34 degrees and 19 minutes. Let me remind you how to plug this into your calculator. So we're going to say 90 minus, and now we're going to do degrees, minutes, and seconds. So we are 34 degrees, so 34 second apps, choice 1, and 19 seconds, second apps, choice 2, and then we press enter. And now I want my answer to the nearest second. So we're going to say second, apps, choice 4. And we're 55 degrees, 41 minutes, and 0 seconds. If I say round to the nearest second, do I need that 0 seconds there? Yeah, we do. Yes.
My calculator said 55 degrees, 40 minutes, and 60 seconds. If I put that on the...
Okay, I would take it. That's fine. Yep.
So even if it says 60 seconds?
Well, 60 seconds is the equivalent to 1 minute, which would make it 41, right?
Yep.
So I'm fine with that. So we had, what was it? 51 degrees, 41 minutes. Was that it?
No, it was 55.
55.
55 degrees, 41 minutes.
55, 41. Okay, thanks. So we found the measure of angle B. Now we want to find the side length of CB. So I'm going to go to CB and I'm going to call it X. Even though we found angle B, I always recommend using the angle they gave you. In case you messed up on angle B, it's not carrying through that mess up to the rest of the problem. So always go back to the given information they gave you. And in this, I know that 17.581 is adjacent, and CB, which is what we want to find, is the opposite. So we go to SOHCAHTOA. And which trig function pairs the adjacent and the opposite? Tangent. Can I ever write tangent by itself? No, I need tangent of an angle. My angle is 34 degrees and 19 minutes. Equals the opposite, because we're dealing with tangent, which is x, over the adjacent, which is 17.581. This just brings us back to algebra. We need to solve for x. So I'm going to multiply by 17.581 on both sides. So you do 17.51 times tangent of 34 degrees and 19 minutes. And this time I'm rounding because I'm finding a side length, says round all sides to the nearest tenth. So we're going to have 11.7 units long. Did we all? Oh, nope, that's wrong. Yeah, because I wrote 17.1, not 17.51. Try this again.
17.581.
Oh, 581. Twelve point zero. 12.0. Okay, so you guys try number 8. Yep, you're trying number 8, and then we'll do the word problems. No, no angles here. No, you could use trigonometry to find an angle, just like we did in part 2. So I called angle B theta and I called AB X. Are you guys stuck on how to find theta? David, no sleeping. All right, let me help you on how to find theta.
Are you using tangent to start?
We are using tangent to start. So I'm going to use theta, and I'm going to use the two sides that were given to us. So we have the opposite and the adjacent. So I'm going to say the tangent of theta is equal to 18.714 over 42.341. Guys, we just spoke about this earlier. How do I get theta by itself? The inverse. Whenever we're solving for the angle, we use the inverse. So theta is going to equal the inverse of tangent of 18.714 over 42.341. We also want to round to the nearest second. And we are going to get, if you plug it in correctly, 23 degrees, 50 minutes, and 41 seconds. And now I'm going to use that angle to find x. Does it matter if I use the opposite or the adjacent? No. I'm going to use the opposite and obviously the hypotenuse, since that's what I need to find. So that's sine. So I'm going to say the sine of 23 degrees, 50 minutes, and 41 seconds equals the opposite, which is 18.714 over the hypotenuse, which is x, because that's so from SOHCAHTOA. I cannot solve for a variable that's in the denominator, so my first step is to multiply by x on both sides to get it out of the denominator. And now that I got it out of the denominator, now I can solve and divide by the sine of 23 degrees, 50 minutes, and 41 seconds on both sides.
But the side lines have to be in, oh no, it's just angles that are in the time units, right?
Yep. So for the side lengths, it's the nearest tenth. So here we should get 46.3. All right, word problems. So the most difficult part, Aaron, about the word problems is setting up the diagram. So you guys set up the diagram for me. Hold it up once you're done. Or you don't have to hold it up if you don't want. If you want to just write it on the paper, I'll go over it anyway. Perfect. Perfect. Oh, what are you trying to find? You didn't label the unknown.
Oh, the
Perfect. Ethan, phone away.
No.
Aaron, phone away. So
Is the 20 up? Not.
no, your 20 is good, your 9.5 is good, but it's saying what is the angle of elevation? So that's not a side, it's an angle, right? What's the angle of elevation? Aaron,
Yeah, sorry.
Aaron. So what should the diagram look like? A 20-foot ladder is leaning against a wall. So here's my wall. Here's the ladder. So the base of the ladder is 9.5 feet from the base of the building. Base means bottom. So this is the 9.5. Everybody had those two marked correctly. But now it's saying what is the ladder's angle of elevation? Remember, the angle of elevation is the angle that's looking up with a horizontal. So here is our angle of elevation. So I have the adjacent and I have the hypotenuse. So according to SOHCAHTOA, which trig function should I use?
Cosine.
Cosine. So cosine can never stand alone. So it's cosine theta equals 9.5 over 20. Aaron, how do I solve for the angle?
The inverse, so it would be close to negative 1.
Good. So theta is equal to, I want to the nearest second. So it should be 61 degrees, 38 minutes, and 26 seconds. So your quiz is going to look exactly like this, same layout and everything, even same number of word problems. So it's basically this with different numbers. All right, so you guys try number 10, set up your diagram. Remember, an angle of depression, very good, has to be made with one ray going down and the other horizontal. An angle of depression has to be made with one side of the angle looking down, the other, perfect, the other horizontal.
The boat's on the ground.
Yes.
Those in the water. I'm starving. I'm so excited for lunch.
It's next period. You're almost there.
I know.
Okay. So from the top of a lighthouse, wait, I'm just setting up the diagram. Are you still setting up your diagram? Okay, so I just want to make sure before people keep going and mess up their problem. So here's our lighthouse. Our lighthouse. So from the top of the lighthouse, 215 feet high, so this is 215 feet, the angle of depression to the boat, here's our boat, B for boat. Now an angle of depression is one ray looking down, but the other from the same point has to be horizontal. So this is my angle of depression. Find the distance of the boat to the foot of the lighthouse. So we're finding the bottom length right there. So what I recommend we do is close this up, make a rectangle. So if the left is 215, the right is 215. If the bottom's X, the top is X, and this is what we need to find. So I have opposite and adjacent. Which trig function? Tangent. So we're going to say tangent of 51 is equal to 215 over x. I cannot leave that x in the denominator, so I multiply by x on both sides. So we're going to have x times the tangent of 51 equals 215. And now we divide by the tangent of 51. So this is not an angle, this is a side length, so we do not do degrees, minutes, seconds, we round to the nearest tenth. So we're going to do 215 divided by the tangent of 51, and we will get x is equal to 174.1 feet. That's their distance. All right, go ahead, set up the last word problem. Set up the diagram for the last word problem.
I hate word problems.
I wasn't even paying attention. Two buildings are 250 feet apart. The angle of elevation to the top, but you don't have an angle of depression. Oh no, there is no angle of depression. I'm lying. Two buildings are the angle of elevation to the top. Oh yes, perfect. Perfect. You both did it perfectly. I thought this was a different kind of problem. Okay, so what should your diagram have looked like? Two buildings are 210 feet apart. The angle of elevation from the top of the shorter building, so here's my ground. Oops, come back. Here's my ground. Here's my shorter building. Here's the taller building. So the two buildings are 210 feet apart, so this distance is 210. The angle of elevation from the top of the shorter building, right here, to the top of the other building is 62 degrees. So remember, an angle of elevation is one ray looking up, the other horizontal. So this is 62 degrees. The shorter building is 70 feet tall. Now, when we draw that horizontal, it's going to make right angles with the building. Determine the height of the taller building. Well, do you guys agree I made a right triangle and a rectangle below it? So if 210 is the bottom of the rectangle, 210 is also the top of the rectangle. I can go ahead and solve for x. When I solve for x, is that my final answer? No, I'll need to solve for x and then add 70. So we have opposite and adjacent, which is tangent. So tangent of 62 is equal to x. What happened? No, it says the angle of elevation is 62 degrees. X over 210. Now, if we're going to solve this, I need to get x all by itself. So I'm going to multiply by 210 on both sides. So x will equal 210 times the tangent of 62. And so x will equal 395.0. But then what are we going to do? I guess, actually, I will round at the end. 394.9525577. And then in your calculators, all you have to do is have that number and press plus 70. And so when you do plus 70, Now you round your final answer. X is equal to 465.0 feet. All right, we're done.